Remember that you can't use a calculator on the SAT subject test in chemistry. And that includes for problems that require logs. So if you remember, this is a question about pH and pOH. pH is equal to the negative log of the H plus concentration. pOH is equal to the negative log of the OH minus concentration. Now, you can't use your calculators for this. So you might wonder, oh boy, well, what do I do in situations where I need to use this, right? I need to figure out what the pH is or the pOH is. Well, if, let's say, you have an H plus of 1 times 10 to the minus 3. If you log this, what you're going to find is that basically you're going to get, so if we log this, when it's simple like this, when it's just 1 times 10 to the minus 3, which is what you're going to see almost all the time on the SAT subject test, the pH is just equal to the exponent negated. So in this case, the pH of this would just be 3. So you just look at the exponent, and that will tell you what the pH or the pOH is in that situation. If this number is not equal to 1, so if it's like 2, 6, 10, you know it's going to be in between 3 and then the 1 beneath it. So it'll be like between 2 and 3. For instance, let's say we had log of 5 times 10 to the minus 3. Well, it's not going to be pH 3, but notice the concentration is higher, so it will be lower than 3, right, because it's a more acidic solution, which means it's not going to be quite 2 yet, because if it were 2, this exponent would be 2. So we know it would be somewhere between 2 and 3. Where exactly, we don't really care about. We can just estimate it, and that's going to be enough for these problems because they're going to make it clear as to which answer is going to be which. They're not going to make you decide between 2.4 and 2.5. It's silly. You can't do it without a calculator. So just remember that as a shortcut. That said, a solution is made by adding 5.6 grams of KOH to enough water to make 1 liter of solution. What is the pH of this solution? So first things first, let's figure out how many moles of this are added. Now it's to 1 liter solution, so that's also going to be the molarity, because remember molarity, which is your concentration, is moles of solute over liters of solution. And that SOL apostrophe N means solution. So let's figure out my moles first. Well, I've got 5.6 grams of KOH, and the molar mass is 56 grams, so I go ahead and divide it. And I get, as you can see by the nice numbers, 0.1 mole. For my molarity then, I've got 0.1 mole over, as they tell us, 1.0 liters of solution. So molarity is 0.1 molar. Now this, by the way, since KOH is a strong base, and therefore dissociates completely into K plus and OH minus, this is also the concentration of the OH minus and the K plus, but we don't care about that. We just care about the OH minus. So what is this? Well, this is the same thing as 1 times 10 to the minus 1, right? So if we pOH this, we're going to get 1, right? pOH is 1. Now remember, be very careful here. We're looking for the pH. So remember that in any given solution, the pH and the pOH add up to 14. So in this case, if my pOH is calculated as 1, my pH has got to be 13. So the pH of this solution, therefore, is 13. So the answer is E. And that makes sense, right? We're putting a base, a very strong base, into solution. So there's no way right off the bat that we're going to have 1, 3, or 7. These are acidic. That's neutral. Doesn't make any sense. So really your decisions are between 9 and 13. And you can see that in this case, because the pH is 1, or excuse me, the pOH is 1, the pH would have to be 13 by this relationship. And that makes sense because we've got a strong base. And yeah, I mean, that's how it goes. All right, so that is the answer for that one. As you can see, there's a lot of information required for it, but obviously acid bases are pretty important, so you got to learn it.